Hi guys, this is Miss Goal. Today's lesson is Module 6, Lesson 5, Surface Area. Your outcomes for today's lesson are students determine the surface area of three-dimensional figures, including both composite figures and those missing sections. First, I'd like you to get some review by completing the opening exercise, and what you're going to want to do is pause the video while you complete the exercise. What you also need to remember is that surface area is the sum of the areas of each side of a figure. So your figure is a pyramid, and a pyramid is made up of a square base and 4 triangle sides where the triangles are all the same. So go ahead and pause the video and complete the opening exercise, and then unpause it when you're ready to begin. Okay, so here is your solution. Go ahead and check it over. If you need to pause to check over your solution, you may do so, and move on when you are ready. Let's take a look at example 1. Example 1 is going to be just like some of the surface area examples that we looked at already this year. And so recall that when we talked about surface area, we learned that surface area is a breakdown of the shape and simply finding the area of all of the faces of the shape. So if we think about this rectangular prism, it's basically a box. And in this box, I know that here I could find the area of this side of the box, but remember that there's always going to be an opposite side to that, which is back here. And so if I want to come up with the formula for surface area of this, I can start by labeling my length, width, and height. So this could be my width, W. This would be my height, and this would be my length. So in general, before I start filling in numbers, let's just come up with a formula for this. So if we just kind of break down the different pieces, you need to be able to come up with this formula because it is not going to be on a reference sheet in 8th grade. So here we have the area of this rectangle. And remember, area of a rectangle is simply base times height. So the base in this one happens to be width, and then the height is actually the height. And then remember what I just said is that this shape here is the same in the back. So we actually have 2 of them. So instead of having to do this over again, why don't we just multiply it by 2? So that takes care of the front and the back. Then we need to take a look at the sides. So the sides here, we know that this would be 12, and that is our length. And we know that this here is our height of 3. So this shape is mirrored on the opposite side over here. So again, there's going to be 2 of them. And we're looking at base, which is the length, and height, which is still the height. Finally, we have the top of our figure, which you can see here has our width of 6, and it has our length of 12. So when I do the base, we could say the base is going to be the width times the length, which is essentially our height in this scenario. And again, there's the top, but there's also the bottom of that box, so that is also going to be multiplied by 2. And at this point, this becomes very simple because we just plug in the numbers that we know. Like we know W equals 6, and height equals 3, length equals 12. So if I just plug in all the numbers that I know, width is 6 and length is 12, then I can evaluate. Just make sure you follow order of operations, meaning multiplication of each of these needs to come before the addition. So when I multiply those, I get 36. 2 times 12 times 3 is going to give me 72. And last one is 144. And so when I add all of those together, I get 252. Now the units on this was inches, and its surface area, and we know that area is 2-dimensional, so that is going to be inches squared. Now we're going to take this idea and step it up a notch for the part B on this. So this is the same figure that we were just using. However, you notice here that they took this block out of our figure. And we're asked to determine the surface area of the figure on the left. So we're trying to find the surface area of this figure. And it's very similar to the one that we just found. However, there's a couple new sides on this figure, and then there's a side that's different about it. So here we have these 2 sides are new, and this side doesn't appear complete, but you'll notice that that side actually just got moved in here. So we still actually can use the idea, if we wanted to, that this side mirrors this side, because when you add the 3, the 6, and this 3, then you would still get that total of 12. So let's just take this by breaking down all of the different pieces. So you can do this in several different ways. I like just saying that I want to find the area. Let's do some of the easier ones. Let's do the outside, front, and back. So how about area of the front and back? So we'll just do a little subscript here to note which one we're looking at. So the area of the front and back. Now again, the front and back are going to be the same, so there's two of them. And it is going to be my width, let's label these, width and height. So this is going to be height times width. So I can plug that in and get 2 times 3 times 6. And that gives me 36 inches squared. So that takes care of the front and back. Now, if I want to take care of this side over here, so the area of the left side. Area of the left side, we'll call this our length. So there's only one of this left side. You could actually consider this other side here, but you don't want to forget that there is also this square here and this square here. So I'm going to break that down and do that differently. So let's just consider this just one side. So we have length times height. So our length is 12 and our height is 3. 12 times 3 is also going to give us 36 inches squared. Now let's work on the sides here. So we have the exterior right side. So area of the right side exterior. And you'll notice that this square here and this square here are actually the same. So we have two of them. And the area of a square is going to be side squared. And so the length of a side is 3. So this is going to give us 2 times 3 squared, which is 2 times 9, giving us 18 inches squared. And then we want to take care of the inside here. Now you'll notice that if this is 3, that means that this is 3. And the height of all of this is 3, so this is 3 inches. So you see that these are also going to be squares. And this is going to be mirrored opposite this. So you can't see it from this angle that we're looking at, but you can tell that this side within this object is also going to be a square. So let's figure out the right side interior. Area of the right side interior. Now that interior is made up of 2 squares plus this rectangle in here. So plus a rectangle. Okay, so the 2 squares, we already know that the squares are going to be side squared plus our rectangle, which is going to be base times height. Okay, so let's fill in those. 2 times the side is 3 squared plus base, the base is 6, times the height is 3. And when I multiply all of these out, now we already know this part here is going to give us the previous one, 18. And 6 times 3 also gives us 18 for a total of 36 inches squared. The last thing we need to figure out is the top and bottom. And what I like to do is break up the pieces so I can see more defined shapes that are easier to calculate the area of. So here now I would have, I want to find the area of this rectangle. And if this is 3 deep, and you can see up here, this is 6 inches. So if this takes care of 3, this section here is also going to be 3. So I'm able to get a width and a length for that rectangle. So let's do the area of the top and bottom. Now, because it's the top and bottom, there's 2 of them. So we'll start off by multiplying it by 2. And this shape consists of 2 squares and a rectangle. Okay, so we have the top and bottom, so that's the times 2. And we would do a base times height for the rectangle. Actually, let's take care of the square first, just because I wrote that first. So we would say we have two squares, so it's 2 times our side squared plus our rectangle, which is base times height. Okay, so we know 2 times the side, which is 3 inches, so 3 squared, plus our base, which is 3 times our height, which is 12. Okay, so when we multiply these out, I'm going to get 2 times 18 plus 36, which gives me 2 times 54, equaling 108 inches. And so finally, remember, surface area is just the total of all of these. So the last thing we need to do is just add these all together. So we'll say surface area is equal to 36 plus 36 plus 18 plus 36 plus 108 is equal to 234, and this was in inches squared. And so that's our final answer. So there's quite a bit of work involved with this, and you really have to break down all of the pieces. So you want to take your time with this and make sure that you really are getting all of the different sides of the figure to make sure you hit on everything. All right, let's take a look at one more example. And this relates back to our opening exercise. So it says a right rectangular pyramid has a square base with a side length of 10 inches. A surface area of the pyramid is 260 inches squared. Find the height of the 4 lateral triangular faces. Now, if I think about surface area, I know that surface area is made up of the area of the base in this figure, plus the area of each of the 4 triangles that make up the sides of that figure. So let's first find out what the area of the base is. Now that base is a square, so essentially that's going to be 10 squared, or 10 times 10, which is 100. And this is in inches, so we'll say it's inches squared. Then I also want to know the area of the 4 triangles. Now, what I do know is I don't know the height, so I can't actually calculate the area of the triangles yet. And that's actually what I'm trying to find, is the height. So instead, let's take what we know is that if we have the surface area, we can isolate the area of all 4 of the triangles by subtracting out the base. So the area of the 4 triangles is equal to the total surface area, take away the base, leaving us with 160 inches squared. Now that's 4 of the triangles. So let's narrow it down to 1 triangle. So if we take that and divide by 4, that's going to equal 1 triangle. So we get 40 inches squared is equal to the area of 1 triangle. Now this is where we're going to be able to find the height. As you guys know, the formula for area of a triangle is equal to 1/2 base times height. So area of a triangle equals 1/2 base times height. So if I plug in the things that I know the area of the triangle is 40, and I know the base is 10. What I don't know is the height, so I'm going to leave that as h. So we can simplify here. 1/2 of 10 is 5. So I have 5h equals 40. And then if I want to solve this, we could draw our wall and divide both sides by 5. It's a one-step problem. And we get h equals 8. So my final answer here is that the height is 8 inches. So this just gives you an example of different ways that surface area can be applied, and this is the type of problem that you should expect to see in 8th grade, where they're not just asking you to calculate the surface area, but rather use the surface area to work your way backwards to find some of the elements within the figure.